Welcome. I'm Will Johnston, Developer Growth Lead here at Redis, and I'm here to talk to you about why JSON Web Tokens are not safe. I have over 15 years of experience in software development, working at companies of all sizes, from startups to the Fortune 50. I also do a lot of video production, particularly on developer-focused topics. You may recognize me from the Redis YouTube channel. Before we get started, I should let you know that you can get $300 off a Redis Enterprise subscription right now if you use the code JWT3. To do this, simply go to redis.com/try-free and sign up. Then, when you create a subscription, add the coupon code. You'll need a valid credit card on file, but the card will not be charged. Okay, let's dive in. In this webinar, we'll be going over the following topics: HTTP sessions, authentication, and authorization, including where to store session data, how the client and server communicate using sessions, and how the server handles authentication and authorization. I'll also highlight a few key problems that people often run into with sessions, and why JWTs seem like a logical solution to these problems. I'll briefly discuss the benefits of JWTs and also highlight why they might leave your app open to security vulnerabilities. Next, I'll discuss some workarounds to JWTs and the complexities of those workarounds. Lastly, we'll talk about how and why so many people choose Redis for session storage. I'll go over the benefits of using Redis for session storage and as a primary database. So without further ado, let's get started. JWTs are extremely popular. I'm sure many of you have either used them or at least used apps that use them in the past. While JWTs do have a place in software development, many top experts at security companies like Okta have discussed potential dangers of JWTs at length. Here you can see some examples of subject matter experts talking about problems with JWTs. However, marketers, content creators, and even course instructors have knowingly or unknowingly continued to promote JWTs. To give them credit, like Thomas says in the quote here, JWTs look like a simple token and are relatively easy to implement. One of the main reasons for JWTs usage is the need for speed. The other reason is that it's simple to use. The last reason is it's a buzzword that makes marketing very easy. The name combines JSON, which is generally well understood and liked, web, who doesn't love the web, and token, which implies stateless and simple. This may make people think it's perfect for web authentication. In reality, it's not. This is a case in which the marketers and misinformed content promoters have beaten out the engineers and security experts. But it's not all bad, because there are regular, long, and passionate debates about JWTs on sites like Hacker News. So there is hope. The amount of debate should give you pause, because security should ideally be a black and white issue. Either something is secure or it's not. Before we get into JWTs, let's take a look at a use case to better understand sessions, authentication, and authorization. Imagine you're using Twitter. You log into the platform, you like someone's tweet, and then you write a new tweet of your own. So you've performed 2 additional actions after you log in. You need to be authenticated and authorized before you can perform each of the 3 specific actions. This is because HTTP is a stateless protocol, which means that the HTTP request doesn't store who you are from one request to the next. Since there are 3 different requests, Twitter servers have to verify if the request is valid 3 different times. After you log in, the server typically creates a session. The session is a container that houses data about a user's interactions with the website or service, and its lifetime is time-bound, but also bound by login and logout actions. A session typically has a user's profile information, permissions such as user, admin, superuser, whatever their role is. Sessions can also contain app-related data, like shopping cart information for retail apps. And lastly, sessions almost always contain an expiration date, after which point the server will no longer validate the session. Managing sessions presents 5 major challenges. Session data needs to be stored somewhere. Since HTTP is stateless, session data must be sent back to the client so that the client can keep adding this information to future requests. The client then needs to send session data back to the server for future requests. The server needs to verify if the client's information is valid, that is, authentication and authorization. For example, whether or not the user who is liking a tweet is a user or an admin, if the session expired or not, etc. Session expiration. At some point, the session needs to expire to force people to log in again for security reasons. Let's look at each of these 5 points and get a general idea of how they work in most applications. If you send session data back to the client, say browser or mobile app, then you risk security issues. Someone could access or intercept the session data, change the data, and access the server. In addition, there could be a huge amount of data that's going back and forth between the client and the server. You might also consider storing sessions in memory on the server. This simply doesn't scale out as you need more servers, and you lose sessions if your server goes offline. So realistically, you must store session data in a database. If you create a session on the server upon login, and then keep the data in the database, how can the client know about it? In order to solve this problem, servers generate a session token that looks like a random string that points to the actual session data in the database and sends it back to the client. The server either sends the session token in the form of a cookie in the HTTP response, or it sends it in the body of the response itself. Here you can see a session token and an example of what the token maps to inside a database. Once the client receives the session token in the form of a cookie or as a token, it keeps this information and adds this token information to every future request. Here's essentially how it works. A user logs in, the server creates a session token, and cookie. The server then stores the session and the session token in a database. The server then sends the cookie that internally contains the session token back to the browser in an HTTP response. Upon every request, the server queries the database with the session to get the actual session back, and then the server checks for 2 things. 1, are you authenticated? Your login data is still valid. It verifies that it's not been tampered with, not expired, not logged out, etc. 2, are you authorized? You can log in, but do you have permission to perform a specific action? In other words, it checks if your role is an admin, a data owner, a user, an employee, a super admin, etc. Each session also has an expiration time, which is at the discretion of the backend developer. Some people expire sessions every 5 minutes, others every 30 days. After that time, the session data will be deleted. And if the user makes a call to perform some action, typically the user will be denied permission. Most client applications will redirect the user to a login page, forcing them to log in again. When they log in, a new session is created and a new expiration time is assigned, and the cycle starts over. If you're using something like OAuth, you'll get an access token and a refresh token. These provide a little bit finer control of when the session expires. For example, the client can use the refresh token to extend the session for an additional time instead of logging people out. So in summary, HTTP is stateless, so to keep track of a user upon login, a session is created. A session is data about a user and their activity. Session data is typically stored in a database. A session token is used to authorize and authenticate a user and is exchanged between the server and the client on every request. The server calls the database on every request to check if a session is valid and get the session information. Now let's continue with the Twitter example and see how the entire process works when you log into Twitter and submit a tweet. So the first step is you log in with your username and password. The server first authenticates the user, then it creates a session token and then stores that token along with the user's info in some database. The server then sends a session token to the client. This token is then stored in the cookie or in local storage of the app, typically in a cookie. Then you write and submit a tweet. Along with your tweet, the app sends the session token through a cookie or some header so that the server can identify who you are. But remember that the token is just a random string. So how can the server know who you are just from a session token? When the server receives the session token, it won't know exactly who the user is, so it sends that to the database to retrieve the actual user's info, such as the user ID, from that token. If the user exists and is allowed to complete the action, i.e. the authentication piece, send a tweet, the server allows them to do the action. Finally, it tells the front end that the tweet was sent. The main problem with this approach is the need to validate the session with the database for every single action the user performs. You effectively need to hit the database n+1 times for every single API call. This slows down the overall response time. There are two ways to solve this problem. One, somehow eliminate the database lookup for users completely. Two, make the database lookup much faster so that the additional hop won't matter. There are three different ways in achieving option one. You could store the state in the server's memory. However, this can cause issues when you scale since the state is only available on a specific server. You could also use what's called sticky sessions. This is when you instruct the load balancer to always direct the traffic to a specific server even after you scale up. Again, this can cause different scaling issues, and if the server goes down, i.e. if you scale down, you'll lose all the sessions. You can also use JSON Web Tokens. We'll investigate how to do this in a bit, but this is typically when people choose to use JWTs. The other option is to simply use Redis. Tens of thousands of companies use Redis for session storage. It's probably its primary use case. With sub-millisecond latency, it's as fast as you are storing this data in the server itself. We'll look into this more later, but first let's learn how JWTs work, including the perceived benefits and potential risks. JWTs, especially when used as a session, attempt to solve the problem of time-consuming, repeated database calls by completely eliminating the database lookup altogether. The main idea is to store the user's info in the JWT itself. This means instead of some long random string, the actual user info is passed in the session token down to the client. And to secure it, part of the token is signed using a secret that's only known to the server. Here you can see what an encoded and decoded JWT might look like. So even though the client and the server can see the user's info part of the token, the second part, the signed part, can only be verified by the server. The pink section of the token here contains the payload, the user's info, and can be seen by both the client and the server. The blue part is signed using a secret string, the header and the payload itself. And so if the client tampers with the payload, say they impersonate a different user, the signature will be different and the user won't be authenticated. Let's look at what this Twitter use case would look like with JWTs. First, you log in with your username and password. The server authenticates you by querying the database. The server then creates a JWT token using the user's info and the secret. No databases involved there. The server then sends the client a JWT. For future activities, the client can just send the JWT token to identify the user instead of logging in every time. Next, say you write and submit a tweet. When you send it, along with your tweet's text, the client will also send the JWT token through a cookie or a header, as with sessions, so that the server can identify who you are. But how can the server know who you are just from the JWT token? Well, part of the token already has the user information. So when the server receives the JWT token, it uses the secret string to validate the signed section and gets the user info from the payload of the section, thus eliminating the database call. If the signature is verified, it allows you to perform the action. Finally, the server notifies the front end that the tweet was saved. In other words, the result of the action the user was originally intended to take. Going forward, For every user action, the server simply verifies that the signed section is correct, gets the user info, and lets the user complete that action, effectively skipping the database entirely. But there's one additional and important thing to know about JWT tokens. They use an embedded expiration time, which is typically set from 5 to 30 minutes. And because it's self-contained, you can't easily revoke or invalidate or update this expiration time. This is really where the crux of the problem lies, but let's look at some other specification flaws. The JWT spec is written more like the HTML spec. In HTML, if you don't close an HTML tag like a div, it's still valid and the browsers continue to display it. The goal is to try to make the best effort to render something in the browser instead of throwing an error. So it's very liberal in that sense. But this causes a lot of problems for browser developers and front-end engineers. Although thankfully, the worst that can happen is just as bad as HTML being rendered improperly. The JWT spec is similarly written. Instead of being very strict in enforcing security rules and having built-in best practices, it provides a lot of workarounds to allow for edge cases and a variety of use cases. These workarounds in turn can lead to security breaches. And just like with HTML, it burdens back-end engineers and library creators who must know all the best practices to avoid these loopholes. However, unlike with HTML, if people don't follow those best practices, it can cause a lot more damage than bad rendering, such as allowing weak authentication. The other problem is because the spec itself is so liberal, back-end engineers need to be very careful when using JWT because what might be technically valid according to the spec might not be secure. Let's go into some potential security issues. JWT allows various algorithms to sign the payload. One of them is the none algorithm. At a high level, if someone specifies the none algorithm, it means that the JWT library should ignore validating the signature completely. So all the attacker needs to do is simply change the algorithm type to none and send whatever they want to the server. The libraries will think that there's no need to validate the signature and will provide access. For example, say the attacker passes alg equals none in the header, and say you are reading the alg from the request header shown below in the rec.header.alg value, which is valid. You could then hit this vulnerability. This might sound contrived, but the solution to this problem is that back-end engineers need to ensure that they ignore the none algorithm. Even Auth0, which promotes JWTs, got hit with a big security issue involving certain JWT libraries that were written to spec, enabling things like the none algorithm. The JWT spec provides a nice way to organize and ensure different claims that could help improve security, but they're all optional. For example, in the example code here, sub, ISS, AUD, and so on are all optional. This puts the burden on developers to follow best practices. If the spec had made some of them mandatory, it would have solved a lot of security headaches. For example, if the AUD was mandatory, it would force engineers to ensure that the JWT for one service, for example, the cart service, doesn't work for another service, for example, the backend office service. Since these claims are optional, they're often not required or configured correctly. To fix this, claims must be set and checked against what is expected. Other considerations to make. Number one, the length of tokens. In many complex real-world apps, you need to store a great deal of information, and storing it in the JWT tokens could exceed the allowed URL length or cookie lengths, leading to problems. Also, you're now potentially sending a huge volume of data on every request. 2. The state needs to be maintained anyway, for rate limiting, IP whitelisting, etc. In many real-world apps, servers have to maintain the user's IP and track APIs for rate limiting and IP whitelisting. So you'll need to use a blazing fast database anyway. To think your app somehow becomes stateless because you're using JWTs is just not realistic. In addition to all the aforementioned issues, the biggest problem with JWTs is the token revocation problem. Since JWTs continue to work until they expire, the server has no easy way to revoke them. Here's why that's dangerous. For starters, logout doesn't really log you out. Imagine you're logged out from Twitter after sending your tweet. You'd think that you are logged out of the server, but that's not the case because the JWT is self-contained and will continue to work until it expires. This could be 5 minutes or 30 minutes or whatever the duration set as part of the token. So if someone happened to get access to that token during that time, they can continue to use it to authenticate until it expires. 2. Blocking users doesn't immediately block them. Imagine you're a moderator of Twitter or some online real-time game where real users are using the system. And as a moderator, you want to quickly block someone from abusing the system. You can't. Again, for the same reason. Even after you block them, the user will continue to have access to the server until the token expires. 3. JWTs could contain stale data. Imagine the user is an admin and got demoted to a regular user with fewer permissions. Again, this won't take effect immediately, and the user will continue to be an admin until the token expires. 4. JWTs are often not encrypted. Because of this, anyone is able to perform a man-in-the-middle attack and sniff out the JWT, and now has your authentication credentials. This is made easier because the man-in-the-middle attack only needs to be completed on the connection between the server and the client. It's also important to note that some people encrypt JWT tokens. This is called JWE, but when you use this method, the client, especially browsers and mobile devices, won't have a way to decrypt them to see the actual payload. At this point, you're essentially using the JWT as a regular encrypted session token, at least from the perspective of web apps and mobile apps. Here is a, albeit slightly sarcastic, flowchart that does a good job of articulating the challenges of using JWTs and the issues with all the workarounds. There are 5 different ways you can try to make JWTs better, but in all 5 scenarios, you'll hit one bottleneck or another. If you change the signing key when you need to invalidate a session, congratulations, you've logged out every single one of your users. If you keep a list of revocations on the server, what happens if that server goes down? Do you just not allow anyone to make authenticator requests? If you store an ID in the token and store the data server-side, congratulations, you've recreated a session token. If you store the JWT in local storage where there's more space, well, now it can be stolen by any JavaScript on the page, including CDN scripts and browser add-ons. If you make JWTs short-lived so a compromised token is not a big deal, your users have to log in all the time. What you should ask yourself is, why do you need to use a type of technology that needs so many workarounds? By the time you implement all the workarounds to your satisfaction, you lose the benefits of it to begin with. The bottom line is that although JWTs do eliminate the database lookup, they introduce security issues and other complexities while doing so, therefore making it risky to use for user sessions. There are scenarios where it might make sense to use JWTs, particularly during server-to-server communication or microservices communication. They make sense there because it's far more difficult for them to be compromised, so you eliminate the need for a revocation list. However, if you're using JWTs for authentication, you should instead use the traditional battle-tested way to more efficiently make the database lookup blazing fast. Then, the additional calls to the database won't matter. Obviously, I was going to bring up Redis at some point, right? If the answer to the problem I've outlined so far is to use a tried and true method, in other words, store the sessions in a database, but to make that database lookup so fast that the additional call won't matter, how exactly can this be achieved? What you need is a database that can serve millions of requests in sub-milliseconds. Thousands of companies serving billions of users use Redis for this exact purpose. With Redis, the additional database call is so fast that it no longer presents a problem. Here's how storing a session works in Redis. First, you log in with your username and password. The server authenticates the user, then it creates a session token and stores that token along with the user's info in Redis. This is done using the set command, and the key is typically prefixed with session, or SESS:. Then the session token ID. The value is the stringified information for the session object. The server then sends the session token to the front-end mobile app or web app. This token is then stored in the cookie or local storage. Next, say you write and submit a tweet, as in our previous example. Along with your tweet, the app also sends the session token through a cookie or header, so the server can identify who you are. But, like before, the token is just a random string. So how can the server use it to identify you? Well, when the server receives the session token, it won't know who the user is, so it sends that information to Redis to retrieve the actual user's info, like the user ID, from that token using the get command. If the user exists and is allowed to complete the action, in other words, allowed to send a tweet, the server allows them to do the action. Finally, it tells the front end that the tweet was sent, with the original response to the original request. And because Redis is so fast, you don't need to send large user data back and forth between the client and server. Just a session token is enough. You can get the actual payload from Redis in microseconds or sub-milliseconds. Since you're not sending the data to the client, it's harder for people to steal. And since the actual data is inside Redis, you don't have to depend on session expiration time. You can just verify it against the Redis database itself. Finally, you can delete the user data from Redis when they log out, so you can always be sure of authentication and authorization. As you can see, it's an age-old approach of storing the data in a database, but by making it blazing fast, you effectively eliminate the speed issue. And it has no security vulnerabilities like JWTs. Since people have been using Redis for session storage for ages, there are plenty of examples of how to implement this in virtually all languages and frameworks. Here's a simple overview of how to store data in sessions in Node.js with Express and Connect. It works the same way in every language. On the right, you can see how to retrieve and manipulate the session data during an API call. In this case, the view count is being stored as part of the session data, but you could really store anything. Redis has been the leading database for caching and session storage for more than a decade now, but over the last few years, Redis has evolved into a primary multi-model database that makes it easy to use Redis for a number of different use cases. For example, Redis supports JSON now, and with it, you essentially have a real-time MongoDB-like database. Redis also has a search module for real-time full-text search, like Algolia. With Redis as your primary database, everything becomes blazing fast. Not just your session storage. In this architecture, all the application's primary data and session data, as well as everything else, live side by side in the same database. While Redis is still primarily used as a secondary database and cache, many Redis Enterprise customers start using Redis as a cache, and after realizing its true potential, they expand to use it as a primary database. I hope you've enjoyed this webinar, and I look forward to seeing you in future webinars and tech talks. If you're interested in learning more about Redis Enterprise, make sure you visit our YouTube channel. Also, check out the Redis Developer Hub at developer.redis.com. If you want to try Redis Enterprise out for yourself, go to redis.com/try-free to get started for free. We even have a deal running now where you can get $300 off using the code JWT3. Thanks. Okay, so some questions came up during the webinar. Let's address these, and please feel free to leave any questions you have here, and I'll try to answer them in the order they come in. So the first question is, can you use JWTs with Redis? The short answer is yes. The long answer is, since JWTs are just tokens, just like session tokens, there's nothing stopping you from treating them like a session token and storing them in Redis. There are even libraries that are purpose-built for helping you store JWTs in Redis. All right, another question that came up is, how do other companies provide JWTs if they're dangerous? Most companies who authenticate using JWTs or provide JWTs either don't use them for authentication, or they actually use them like sessions, as I described earlier. So they encrypt the JWTs and the client doesn't have access to them. All right, another question here. We use JWTs. Should we migrate away from them? To be honest, the easiest thing to do is to continue using JWTs, but start encrypting them and use them as your session token. Then you can store them in Redis, and this way most of your business logic doesn't have to change. Okay, Arun asked, in the example where user sessions are stored in Redis, how can the value of TTL be decided? For those who don't know, when you store a key in Redis, you can provide a TTL, or time to live, after which point the key will automatically get removed from Redis. When people use Redis for sessions, they typically use the TTL to handle expiring session tokens. As for what the TTL should be, that's a decision that needs to be made by the developer and your internal security group. Some developers like to expire sessions more often than others, but keep in mind, if a session expires, it forces your user to relog in. All right, someone asked if Redis can be used on-prem. It definitely can. Redis runs within Docker on both Linux and Windows, and that makes it relatively easy to run locally as well as on-prem. With Redis Enterprise, you can even run Redis in a hybrid cloud scenario where some Redis instances are in the cloud and others are on-prem. The way this works is Redis Enterprise sets up a cluster of Redis instances that all operate in lockstep as a single distributed database. That's basically how many people scale their Redis usage. All right, somebody asked if Redis as a primary database can support RDBMS like Postgres. Redis isn't necessarily a relational database, and most people probably don't know this about Redis, but with Redis Enterprise, you do have the ability to store graphs and model complex relationships. Redis Graph uses the Cypher language as opposed to SQL. In addition, you can store and search embedded JSON documents like you would in Mongo. So standard NoSQL data modeling patterns apply with Redis Enterprise as well. The next question is, what if I store a revocation list of invalid users? If you keep a revocation list, so what this means is storing a list of either revoked tokens and not allowing those tokens to be used, or storing a list of revoked users in general. If you do this, you're basically breaking the key feature of JWTs, which is to avoid database calls. Not only that, revocation lists are pretty hard to scale and maintain. Next question. Can you show me the slide where you talked about security experts? I will try to get back to that screen really quick. Hold on. It's back near the beginning, so let me scroll back here. If I miss it, let me know. Okay. It was very close to the beginning. But the point for showing these is this webinar and the ebook that this webinar is based on came out of several, oh, here it is. Okay. It came out of several years of security experts kind of highlighting security issues with JWTs. And that's what most of the information in this webinar is based on. And like I said earlier, JWTs have become super popular despite the worries of many security experts. Okay, someone asked, is it okay to run Redis on Windows running Docker, or should that be avoided? Oh, it's perfectly fine to run Redis in Docker for Windows. This is actually how I run it myself. Okay, next question. We use HTTPS. Are we still vulnerable for man-in-the-middle attacks? The answer to this question probably warrants another ebook and another webinar. It's pretty nuanced. In short, HTTPS does help reduce the risk of man-in-the-middle attacks, but it doesn't mean that it's foolproof. Generally speaking, using HTTPS, or more broadly SSL, is table stakes for any application, but that doesn't mean that you completely mitigate man-in-the-middle attacks. Okay, someone asks, we use a complex system to cache sessions and data with a sync mechanism to broadcast to all servers to clear the sessions. Can Redis replace all that? This is a really good question. Yes, Redis Enterprise lets you set up a cluster and run Redis across several regions in active mode. What this means, in short, is that you can read and write to any of the Redis instances across the network. And behind the scenes, Redis Enterprise takes care of that synchronization. And it even takes care of conflict resolution using CRDTs. Redis Enterprise has rules set up for how to handle conflicts for each data type that you store in Redis. And in the event that a region goes down, users will still be able to write and read from other regions. Then, when a region comes back online, it syncs with the rest of the network and continues as though nothing ever happened. And I should point out that all of that is done for you. So as a developer, you don't really have to think about writing any sort of synchronization mechanism on your own, which is really nice. Okay, last question. How should I decide to store my data, for example, between Redis and Mongo? This is another good question. I'm sure most people are aware, but for those who are not, Mongo is a JSON document database. Lots of people use Mongo as their primary database and still use Redis for caching. With Redis Enterprise, you can actually store and search JSON documents, same as with Mongo. So my recommendation would be to cache your data in Redis using JSON, same as you would with Mongo. On the whole, the same patterns and practices that apply to storing data in Mongo also apply to storing data in Redis. Any more questions? Nope. Okay, that looks like all the questions we have. Like I said, I appreciate everyone for showing up. Hopefully this webinar was helpful for you, and I hope you have a great day. Thanks.